Introduction. Arun, how much you scored in science last year?
Teacher, 72.
And how much in maths?
Teacher, 84.
72 in science and 84 in maths. Okay. Shraddha, now you tell me, how much did you score in science and maths?
Teacher, I scored 86 in science and 85 in maths.
Okay. 86 in science and 85 in maths. Pratik, you tell me now.
Teacher, 67 in science and 72 in maths.
All right. Can you see? I have written your marks in this bracket. What does this represent? Anyone? This represents matrix. Today, we will learn what matrices are and its operations. Come, let's start. Objectives. At the end of this lesson, you will be able to define matrix, explain order of matrices, write different types of matrices, define zero matrix, understand equality of matrices, understand addition of matrices. Definition of matrix. A matrix is a way to organize data in columns and rows. A matrix is written inside brackets. Each item in a matrix is called an entry. Look at this matrix. It has 2 rows and 3 columns. The entries of the matrix below are 2, -5, 10, -4, 19, 4. Order of the matrix. The order of a matrix refers to the number of rows and columns of a given matrix. By convention, the order of a matrix is given by number of rows by number of columns. Here we can see 2 pictures of the same matrix with the rows and columns highlighted. The order of this matrix is 2 by 3, that is 2 rows by 3 columns. Matrix notation. In order to identify an entry in a matrix, we simply write a subscript of the respective entry's row followed by the column. In matrix A, we write A23 to denote the entry in the second row and the third column. A23 indicates the row number 2 and the column number 3. Column and row matrices. Column matrix. A matrix which has only one column is called a column matrix. Example of column matrix. A is equal to column wise 21, 17, 9. This matrix has 3 rows but only one column, so it is a column matrix. Its order is 3 by 1. Row matrix. A matrix is said to be a row matrix if it has only one row. For example, row-wise 3, 5, 1 is a row matrix as it has only one row. Square matrix and diagonal matrix. Square matrix. An m by n matrix A is said to be a square matrix if m is equal to n, that is, number of rows is equal to number of columns. For example, A is a square matrix of order 3 by 3. Diagonal matrix. In a diagonal matrix, all the elements above and below the diagonal are zeros. For example, B is a diagonal matrix. Scalar and identity matrices. Scalar matrix. A diagonal matrix in which all the diagonal elements are equal is called scalar matrix. Look at this matrix. It is the diagonal matrix with the diagonal elements same, that is 7. Therefore, it is a scalar matrix. Identity matrix. A square matrix in which all the main diagonal elements are 1s and all the remaining elements are zeros is called an identity matrix. Identity matrix is also called as unit matrix or elementary matrix. Identity matrix is denoted with the letter n by n, where n by n represents the order of the matrix. Zero matrix. A zero matrix or null matrix is one which has all its elements 0. Here is a 3 by 3 zero matrix. These are 3 more examples of zero matrix. The zero matrix is denoted by O. Equality of matrices. Two matrices are equal if they have the same order and the corresponding elements are identical. In other words, say that A n by m is equal to A ij and that BP by Q is equal to B ij, then A is equal to B if and only if n is equal to P, m is equal to Q and AI, j is equal to Bij for all I and j in range. Matrices P and Q are equal. Here are two matrices which are not equal even though they have the same elements. Example of equal matrices. Given that the following matrices are equal, find values of x, y and z. For two equal matrices, they must have the same size and shape and they must have the same values in the same spots. Or we can say A11 must be equal to B11, A12 must be equal to B12 and so forth. Therefore, by equating the corresponding elements, we can solve for the variables x plus 3 is equal to 6, x is equal to 3, y is equal to minus 1, z minus 3 is equal to 4, z is equal to 7. Addition of matrices. Matrix addition is the operation of adding two matrices by adding the corresponding entries together. Two matrices may be added only if they are of the same order, that is, they must have the same number of rows and columns. Let's add these matrices. We need to add the pairs of entries and then simplify for the final answer. Row-wise, first row 0, 1, 2. Second row 9, 8, 7 plus row-wise, first row 6, 5, 4. Second row 3, 4, 5. Row-wise, first row 0 plus 6, 1 plus 5, 2 plus 4. Second row 9 plus 3, 8 plus 4, 7 plus 5 is equal to row-wise, first row 6, 6, 6, second row 12, 12, 12. So the answer is row-wise, first row 6, 6, 6, second row 12, 12, 12. Did you know? If A and B are not of the same order, then A plus B is not defined. For example, if A is equal to row-wise, first row 2, 3, second row 1, 0, B is equal to row-wise, first row 1, 2, 3, second row 1, 0, 1, then A plus B is not defined. Addition of matrices is an example of binary operation on the set of matrices of the same order. Summary. Let us summarize what we have learnt. A matrix is an ordered rectangular array of numbers or functions. A matrix having m rows and n columns is called a matrix of order m by n. Aij by 1 is a column matrix. Aij 1 by n is a row matrix. An m by n matrix is a square matrix if m is equal to n. A is equal to Aij m by m is a diagonal matrix if Aij is equal to 0 when I is not equal to j.